Hey guys, let's solve the leetcode's daily challenge problem of today. Minimum time to collect all apples in a tree. So we are given such an apple tree. I copied this tree here, and all those routes are undirected, which means we can go from 0 to 1, and we can also go back from 1 to 0. And we are also given such a 2D vector where we know like 0, 1, 0, 2, 1, 4, 1, 5, 2, 3, 2, 6, they are connected nodes. And we are also given such a Boolean array which tells us where we have an apple. For example, in this example, we have apples at here index number 2, 4, and 5. So we are asked to find out the minimum edges we have to pass through to collect all the apples and go back to the top node, which is node 0. So how can we solve this problem? As you can notice, in this example, the answer is shown in those green lines here. 0 to 1, 1 to 4, and back to 1, go to 5, back to 1, back to 0, go to 2, and back to 0. So you will notice like routes number 3 and 6, they are never visited. And why? Because the answer is they don't contain an apple on this node, and also they don't have a subtree which contains an apple. So actually we can think about this problem like this. We can see whether we need to go beyond a certain node by checking whether its next node has an apple, or whether its next node has a subtree which contains an apple. So for example, if we are at this position here, we will notice like for the next level we have two nodes. There are not apples on those nodes, yeah. And also for this node, it doesn't have a subtree which contains an apple. Actually, it doesn't have a subtree. And for this node, it's the same situation. So we don't need to go beyond this node 2, right? So we are done here. But however, for example, for this node number 1, we can check like, okay, its next node, we have number 4 here. And what happened here, there's an apple on node number 4. So we have to go beyond this route. And if we want to go this direction, we have to go back, right? In order to reach to 0. So here we need to plus 2 if our case existed, if we have to go beyond this level. And also for this route, similarly, there's an apple here. So we have to go downwards and then go back. So we need to add 2 here as well. So in total, here we'll return 4. And similarly, here for this node 0, as here we already have 4, and we know like there are some apples in its subtree, so we have to visit this subtree. So we have to plus 2 here. We will return like 6 here on this left hand side, and on the right hand side we have to return 2 because we need to go to route number 2, right? So in total we will return number 8 at this top route. So let's code it up. This solution, actually it will be like a DFS solution, but first I would like to construct such a tree, yeah? Such a tree. So I will use a hash map maybe. And I will have the current node as the key and the vector, integer vector, as the value, which represents like node 0 is connected to node 1 and 2, node 1 is connected to node 1 and 4. So I will call it map. Okay, so then let's first construct this hash map. So let's iterate through these edges. And we will check if we don't have such a key value for our current nodes. Edges I0, right? So if this is equal to end position, we will in place this value. So in place this, and we need a vector here, so matter and we will copy this, so we will push back the number at the first position, which means push back this one. So here we will push back this, we in place this, done. And if it already exists, it's actually very easy. We can just call this index 0, and we will get that vector, so we can push back index this value, right? So we are done here, and we will construct the other way around, which means like the route from 1 to 0, 2 to 0, the backward route. So I will just copy this, and I will just change this 0 to 1, and this back 0, and in place this, and in other case I will just reverse this. So I think we are done for this tree, and now we can construct our recursive function. So I will just call DFS, and we want to pass in this vector here, and also our current node. So I will call it current. So what we will do here is we will just first we will define a total value, which is 0, which represents the total edges, and now we will just loop through our we will loop through this tree. So we will start from root number 0, and we will check the child of each node, right? So what we will do is we will get the child, so it's like the map current size, and we will check whether the child of the current node has an apple, or whether the subtree of the child of the current node has an apple. Yeah? So here I will define a integer which called subtree equals to we will recursively do it recursively, so we have to visit now we have to visit this map, this child, so we will visit it like this, and now we can check if its child node has an apple, which can be done like has apple. Let me copy this, I'm just lazy. This, or if there's some apple on the subtree. So in this case, we have to visit beyond this current level, so which means we need to plus 2 for our total number. Yeah. So total will equal to total plus 2 plus its subtree, right? Otherwise, we don't have to go beyond this root, so we don't need this plus 2. Okay, so I think it looks good, and we can return total here. So now I think it looks pretty good, and we can call our function. It's okay, under this for loop here we can just return the DFS, and our has apple vector, and start from 0. So let's run it. Not able to provide a call operator. Here has map current. We did pass this in, right? And what happened here? Vector, so this is not correct. We have to use this one. Sorry, I'm confused. This is a vector. Great, let's run it again. Oh. Stack overflow, which means sorry, yeah, I forgot one thing important. So as you can see, when we travel from, for example, here to here, the next step we should go this way, right? We couldn't choose this route, so otherwise we will fall into this circle. So when we go this direction, we have to erase this route. Sorry, I forgot something important. So here I would, before we go recursively, I have to erase the reverse route. So I will find out this route first. So position, find. Okay, I need to go to this map and current I, right? So map. This one, yeah. Map. I want to find this vector of this key value and vector. How do we use find? We use this begin and okay, and I want to find the value of parent node, which is our current. Yeah. So then I will use this iterator to erase this root. So I will take this vector dot erase and I will just pass in this position. Okay, so hopefully it works right now. Take a look. Yes, great, it works. And now we are going to submit. Great. So as you can see, this solution is not the optimal solution, but it's pretty efficient because we are only going through the whole tree once. So thank you for watching and see you next time.